Hi, I'm Tim Fox, and I'm here to talk to you today about large-scale deep learning with BigDL. Little about me. I'm a data engineering and data science practitioner and a partner and principal at Elephant Scale. At Elephant Scale, we do training in big data, AI, deep learning, and machine learning. And I'm an author of data science in Python on LinkedIn Learning and an open source contributor to projects such as BigDL. Okay, I'm going to start out with a quick roundup of AI, machine learning, and deep learning. Now, AI is simply a broad category which talks about machines being able to carry out smart tasks, and that can mean a lot of different things. One subset of AI is machine learning, or ML. It is a type of machine learning, it's a type of AI that allows software to learn from data without being explicitly programmed. And deep learning is a subset of machine learning in which we use neural networks to solve some hard problems. Okay, some applications for deep learning are applications like self-driving cars, which uses machine learning for image recognition in order to determine the edge of the road signs, cars in front, etc. Facial recognition is another common application. Facebook images and is able to manually tag and from a data set and then automatically detect faces in uploaded photos. So a bit of history of deep learning. So neural networks have been around for some time, but there's some early attempts there that didn't quite succeed because of a lot of reasons. Compute power being insufficient, training data sets being insufficiently sized, and the lack of the ability to parallelize. But now we have several things that have made our efforts more successful, one of which is big data. So now we have the ability to have lots of data to train our models. The big data ecosystem, we have platforms like Hadoop, Spark, NoSQL, etc. as open source, and they are able to help us to have an ecosystem that is friendly to big data. And then we have big compute. So cloud platforms like AWS, GCP, Microsoft Azure, etc. give us the ability to have very affordable scale for being able to scale up on our compute. So you can see there some of the costs that are associated with that. It also gives us a flexibility of having dynamic workloads. There's a number of different projects around the AI software ecosystem, and many of you are probably familiar with libraries in languages like Python and R, which give us the ability to do general machine learning. Scikit-learn and many of the CRAN libraries in R give us that. We can also do distributed machine learning using H2O and Spark MLlib for that. Now, on the deep learning side of things, we generally have specialized frameworks for that. And many of you might be familiar with deep learning frameworks like TensorFlow, Theano, Caffe, etc. And there are some efforts now on doing distributed deep learning, and one of which I'm going to highlight today is BigDL. In the past, a lot of machine learning was done on a single computer with a lot of memory. And in fact, a lot of machine learning libraries and deep learning libraries are basically single node based. They do not easily allow us to extend our workload into a cluster. However, big data tools we have today like Hadoop, Spark, etc. allow us to do machine learning algorithms at scale distributed across the cluster. Now, you're probably familiar with a number of the modern deep learning frameworks that we have, TensorFlow, Keras, Theano, etc. So this is part of the modern ecosystem we have in deep learning. Now, for scalable machine learning on clusters, you may be familiar with Spark ML, which is designed to give us affordable, that is open source, scale with traditional machine learning. However, it does not cover deep learning so much. Now, BigDL brings deep learning to Spark, and we're going to be talking about that in the rest of this series that we have. TensorFlow is a Python and C++ based library, which is a deep learning library. It runs on CPU and GPU, etc. And there are many other similar deep learning libraries as well, Torch, Theano, Caffe that we mentioned as well. Now, on the cloud, we have a lot of both pre-trained models as well as API managed based machine learning, such as Google Cloud ML, Azure ML Studio, Amazon Machine Learning, etc. Okay, so let's get to BigDL. So what is BigDL? Well, it is a distributed deep learning library built on top of Apache Spark. And it's designed to give us feature parity with popular deep learning frameworks like Caffe, Torch, TensorFlow, etc. And it also gives us high performance, which is powered by the Intel MKL, multi-threaded programming, etc. And it can, most importantly, scale to huge data sets. And it builds on top of Apache Spark and Apache Hadoop and other frameworks in order to achieve that kind of massive scale on huge data sets. And it is open source. The version 0.3 was just released. BigDL runs as a Spark application, similar to other Spark applications like Spark SQL, Spark MLlib, and Spark GraphX and other things. It supports Scala and Python, It is natively written in Scala. It uses Spark's other features like in-memory compute on the Tachyon and Luxio, integrated with Spark ML and streaming, and allows us to do easy development with Jupyter Notebook. Now, comparing BigDL to other deep learning frameworks like TensorFlow, Theano, Caffe, and others, BigDL gives us a Scala engine with a Python front end. Now, TensorFlow gives us a C++ engine with a Python front end. Acceleration with BigDL is primarily CPU based, which fits in well with our native Hadoop and Spark clusters. TensorFlow relies on GPU processing for maximum performance. BigDL runs natively on Spark and Hadoop, whereas most other frameworks do not run natively. They can, at best, access Hadoop data as a client only, and that's true of TensorFlow as well. BigDL relies on Apache Spark for massive scale. Other deep learning frameworks like TensorFlow do not support massive distribution out of the box, unfortunately. BigDL runs TensorFlow models, and so in summary, BigDL is going to be excellent for distributing our deep learning models to massive scale on big data. Now, BigDL helps us in balancing our needs between big compute, giving us fast linear algebra, the Intel MKL library, and big data, which gives I/O parallelization to run on large clusters with many CPUs. It allows us to run on Apache Spark and works with the Hadoop ecosystem via Spark. Now, if you're not familiar, Hadoop is the big data platform for on-premise deployments. And the fact that BigDL is part of that ecosystem is a huge advantage in terms of massive scalability on big data. It also plays nicely with other frameworks. For example, TensorFlow and Caffe models are available to use at scale in BigDL, and we can train new models based on existing TensorFlow and Caffe models. Now, what about GPU and CPU? Now, GPUs, of course, have created a lot of excitement in the deep learning community. And in the past, CPU has not been vectorized for parallel compute, which meant that in the past, GPUs were much faster for deep learning. However, modern Intel Xeon CPUs have vectorized linear algebra that, when properly optimized, can approximate the speed of GPUs and allow us to do faster I/O performance for big data. Now, the Intel MKL, or math kernel library, gives us highly optimized, multi-threaded, and vectorized math functions that will maximize the performance on our processor family. It uses industry standard C and Fortran APIs for compatibility, and it allows us to distribute optimized code for our processor. And you can see here that deep learning performance, when properly optimized for the Intel math kernel library, can be dramatically faster than an unoptimized code and approach the speed of GPUs. So CPUs actually have a lot of advantages for big data. For one thing, our existing big data infrastructure mostly runs on CPU-based instances. So we can leverage all the CPU-based instances that we have. And since BigDL can run on those effectively, that gives us a really great advantage for that. It turns out that although ML and deep learning can be some of the most exciting and interesting parts of our data pipeline, actually speaking in terms of code, it tends to be a relatively small piece of a larger puzzle. We generally have a number of different pieces of the puzzle, for example, like configuration, data collection, feature extraction, etc., and infrastructure that we need. These are going to be running in the big data ecosystem on Hadoop and Spark, and being able to run on a scalable platform like Spark helps us simplify the complexity, avoiding having to have separate clusters, separate nodes, etc., to do our deep learning workloads. It basically fills in the gap. Big data up to heretofore didn't really have much of a deep learning component that we could use. It allows, though, us to use the architectural principles that we've learned in big data, sending compute to data rather than the other way around, using data locality of Hadoop Distributed File System, HDFS, and other similar file systems as well, and utilizing cluster managers like Yarn and Mesos. Some of the use cases we can use for BigDL are things like fraud detection, sentiment analysis, and many others. And we have a GitHub here that I show here that you can see a number of different use cases we've outlined. Okay. So I'm going to show you here how to run BigDL. So we have offered several different options for getting you started immediately in developing your BigDL apps. One of which is a Docker container, which I'm going to demonstrate in this video. We also additionally have a VM sandbox that will be better for some users, and I'll explain the situations where that can be true as well. And also we have a deployable cloud-ready Amazon AMI ready for deployment in the cloud as well. So we have a lot of different options, and it's our goal that you should be able to immediately get going with BigDL. Let's talk about how to start BigDL from using the Docker container. Now, Docker is a great way to go if we have a Mac, a Linux machine, or if we have a Windows box which is running Windows 10 Professional with Hyper-V installed. So if that fits, then we should proceed ahead with Docker for the Sandbox. If not, we may want to consider using the Elephant Scale Sandbox VM, which we can download for VMware or VirtualBox, and we'll talk about that in a minute. So proceeding ahead with Docker, let's go and first ensure that we have Docker downloaded and installed on our local system. Now, I'm running a Mac, which means I'm going to go to the docker.com site. I'm going to go click on Mac, and I'm going to go ahead and download that from the Docker store and click on Get Docker. Okay, so you see now that Docker is downloading from my platform, and I'm going to go ahead and click on this. This may look a little bit different on Windows or Linux, but nonetheless, we should follow the instructions for performing the installing the Docker application here like this. All right, great. So, now that I've installed Docker, I'm going to go ahead and check that Docker is running. Here I can go and see, indeed, Docker is running on my platform. So I do have it running. That also will enable the Docker command to come from my command line, which is what I'm going to do. The next step is I'm going to go ahead and I'm going to pull the latest image of the Elephant Scale BigDL Sandbox from Docker Hub. So to do that, I'm going to open up a command line prompt. I'm going to type in docker pull elephant scale / BigDL -sandbox. Now this may take some time at the first time. It's going to go ahead and download, and eventually it's going to get the Elephant Scale BigDL Sandbox. I can then say docker images, and that is going to show me, among other images possibly, the Elephant Scale / BigDL image available. Now, the next step is to go to GitHub and download and clone the latest version of the Elephant Scale BigDL tutorials. So let me just go to GitHub, make sure that I have this correct. So it is github.com/intel-analytics /BigDL training. I'll go ahead and select the link, and I'll go and I will clone the repository here. So I'll say git clone space. Great. So you see here that by cloning the Git repository, it created a directory called BigDL-tutorials. So I'm going to go there. And inside there, I have a script called run BigDL docker.shell. And I'm going to pass in the name of my sandbox, which is Elephant Scale / BigDL Sandbox. Okay, so notice it's running a script. It is going to then load Jupyter Notebook. I'm going to select the link, and I'm going to go ahead and enter the link in my browser. Now, one thing that the Sandbox is going to do is it's going to take my local directory, which consists of my notebooks and other files, and it's going to put them under a directory called work. So when I put that there, notice that I have all of the same files that I have here in my BigDL tutorials GitHub location, including all the notebooks. So let me go back to Jupyter, and I'm going to click on notebooks, and there's one notebook in particular I want to run now. It's called testing123.ipython notebook. So this will enable me to make sure that my connections to both Spark and BigDL are running properly. So as you probably know, when we are running a Jupyter Notebook, we can click on the cell and we can hit run. And notice here it's connecting to the PySpark shell, which is excellent. That means that I'm running properly. Now I am going to test my connection to Spark. I'm also going to test my connection to BigDL by loading some imports from BigDL. I'm going to then do a hello world of BigDL, where I'm going to instantiate a simple layer of neural network. And notice that it seems to be working properly. It created my layer, and so all is looking good. And so now I can be confident that my notebooks using BigDL will be successful. And I can move on to one of the other examples from the notebooks. And if you'd like to see that, please follow me on the next video because I'll be doing that there. Okay, so let's talk about the Sandbox VM. As I said before, this is a good option for Windows users especially who may not have the capability of running Docker on their systems, and or those with other systems that may allow you to prefer a VM versus a Docker container. So let me illustrate this. So to do this, we should open your browser and go to elephantscale.com/sandbox and go to download the VM image here. So click on the download link and it shall start downloading now. So it's a large file, about 13 GB, so you may have to wait a bit for that to actually load. So once that's actually happened, you can open that up, and then you can take that OVA file, that's what it's called. Depending on your platform, you can then select that, and that should open up VirtualBox, which you'll need to have that available. So if you haven't already gotten VirtualBox, you can go ahead and download VirtualBox by opening up your browser and doing that. So that would just be go to Google, search for VirtualBox, and download VirtualBox for your platform. Okay, so once you have VirtualBox installed, you can go and start it up, and you can do an import appliance here. Go and find the location of the download. So here we have it here. So go ahead and click on that and select that, and it will create the settings that you're going to need for your VM. Okay, and it will spend some time loading that. Once things are then loaded, you should have your virtual machine here, and that will start your machine. The login name for the machine is student, and the password is BigData123. So go back to your VM, wait for it to start up. Then once you log in with those criteria, you'll have a Linux system set up there. So you'll be a student, and it will have a number of different applications already set. Okay, log in as student, as I said before, BigData123. Go ahead and open up a command prompt. And we can say git clone. It's github.com/intel-analytics/BigDL training. Then once we have that, we can go to our BigDL tutorials directory, and we can run here, run BigDL native. And the reason why we're doing that is we're not running Docker here, we're running native. Okay, and so you see that running, and so we have that running. But first, we're going to have to install Spark. So to do that, we'll go to Files, and we'll say tar xvf files spark 2.2 -bin -hadoop 2.7.tgz. And we'll move that to Spark. Okay. So now let's go and to our BigDL tutorials directory, and we'll do run BigDL native.sh. Okay. So now we're starting Jupyter, and so I can go and open this link up here. And you can see that our Jupyter notebooks are now running. And we can go to the testing 1, 2, 3 notebook. And we can watch this work as we did on Docker. Great. So now we have the BigDL running in the sandbox.